If you're just trying to estimate, what the distance is across this room, and you just want an estimate, okay, you don't care too much. Where do you care? An Olympic swimming pool where they're setting records. You don't want yards, and they call it the 100-meter world record. I mean, well, you would want that, but you've got to be very careful. It's not a direct change. And if you're a super good swimmer, hey, that makes a big difference when they're talking hundredths of a second for world records. Okay, so we use meter sticks when we want to go after lengths, or those metric rulers that you used in the laboratory. And then a fourth one, we measure time. Luckily, all over the world, we do this the same way. The only debate is about daylight savings time or not. So basic unit here, generally, we say is the second. And we usually just abbreviate it SEC. Occasionally, you see it just as S. Now, I had gotten started last time, and I did talk a little bit about the prefixes that are used in the metric system, and there's a load of them. But there are 3 of them that we use a whole bunch, and so I want to go through each of these just to show what's common, because we don't use all the various prefixes. So let's take mass first, and just general, go over here. Kilo, abbreviated with a small k usually, although sometimes you see a capital K. That means 1,000, always. That's a very common one. And then the others I had for you, milli and centi. Small m for this, so you can see confusion. M for meter, M for milli. So small m, and this means 1,000.
And then small m?
Small m.
I think you said for maybe to use that.
Yeah, I know. Life is complex.
Oh.
Yeah, life is complex. Yeah, and in English, we only have 26 letters of the alphabet. And lowercase, capitals, whatever. So sometimes, N up here can stand for nitrogen. Later in chapter 8, it's going to stand for something else as well. So life is complex. Okay? So M can be meter, M can be milli. But you can tell from context, I think. And then centi means 100th. And of course, just to get versatile, you could write it like this, or, and give me a power, to the third. 1 times 10 to the third, or, and I'm not even thinking sig figs here, 1 times 10 to the what? Minus 3. And this one, 1 times 10 minus 2. Okay. So be ready for them either way. Now, the thing about these is we can tack them on to anything. And so whatever word follows kilo, it means 1,000 of those. And so let's take a look at mass and what is ordinarily used. Okay. We use kilogram. And 1 kilogram, of course, is 1,000 grams, because we translate. Kilo means 1,000, G follows it, so that means 1,000 grams. Don't try to memorize a lot of this stuff, because you're going to be able to translate it. So 1 kg translates K for 1,000, 1,000 grams. Now that is a statement of fact. I can take that statement of fact and I can turn it into conversion factors. I can write 1 kilogram is 1,000 grams, but it's equally true the inverse of that. And sometimes we use one, sometimes we use the other. So 1,000 grams is 1 kilogram. And I hope as I go through this you all are bored silly because you've heard this so many times and you're really good at it. However, when I see the quizzes and stuff, in most of my classes, people still stumble over some of this. Okay, so let's take the time to go through. Now, let's go in size. Let's go here. 1 centigram. That one just isn't used. Centigram just never caught on. So let's jump just to here. 1 milligram. Milligram. Okay, if we translate, it's this many grams, but I want to state this a slightly different way. If, and listen carefully, if each of a gram, it must take 1,000 of them to make a gram, right? So instead of writing it like this, here's what I'm going to say. 1,000 milligrams is equal to 1 gram. Okay, and see how we can reason that out? Now, I can take this statement of fact. I can say 1 gram is 1,000 milligrams, or 1,000 milligrams is 1 gram. And that's just about all that's caught on. So we talk grams or kilograms or milligrams. Why do we do this? Okay, we switch for what's convenient. We do the same thing in the English system. Okay, in the English system we have ounces, and we have pounds, and we have tons. Okay, if I want somebody's weight in the English system, do we give it in tons? No. Okay, we give it in pounds. Would it be realistic to give it in ounces? Of course not. It'd be a huge number. And so we do what's convenient. We use pounds for people. Okay, if we're talking the metric system, okay, you check into the hospital and they want to see how much you weigh, and let's say that hospital is using the metric system. Okay, would it be smart to give that person's weight in grams? No. I mean, a fairly small woman could be 50,000 grams. Okay, no woman wants to hear they're 50,000 anything for weight. Okay, so we go to kilograms for people because it's a smaller, nicer number to work with. Okay, but how about medication, pills? Occasionally, like vitamin C, it's 1 gram, but usually what they do is medication is so many milligrams. And so your tablet of whatever it is you're taking, maybe 25 milligrams, maybe 0.25 milligrams, it depends what it is. But if it's something super small, we go to milligrams. Okay, so we switch around, and we use this for mass. Okay, let's take a look here. I think I had volume a second that I did. Volume, the basic unit was the liter. Kiloliter never has caught on. Because when you think 1,000 of these in a normal laboratory, we don't work with volumes that big. Now, if you were in the refinery business or making beer or something, yeah, you might have vats that contain that much. But we use liter and we use milliliter. And those are about the only two that we use. Okay, here's the reasoning, the translation. A milliliter. Okay, each milliliter is 1,000th of a gram. Or pardon me, I said that all right. 1 milliliter is 1,000th of a liter. Okay, so let's translate. That means it takes 1,000 milliliters is equal to 1 liter. That's a statement of fact. And then I can take this fact and let me turn it into conversion factors. 1,000 mils is 1 liter, or 1 liter is 1,000 milliliters. We in science use milliliters, but people in medicine use cc, and you ran across this in lab 2. cc is abbreviation, and it really stands for cubic centimeter. You know, you have a cube that's 1 centimeter by 1 centimeter by 1 centimeter. 1 cubic centimeter locally is exactly 1 milliliter. So you could do a direct conversion. That's why you could compare when you had those little metal cylinders. One way you measured the volume of that metal was, let's see, volume was pi, radius squared times height. Okay, so you had centimeter times centimeter times centimeter, or cubic centimeters as your unit. But then you turned right around and you did it by water displacement, and that was milliliters because of our graduated cylinders. So 1 cc, as medical people say, or 1 cubic centimeter is 1 milliliter.